In today's discussion, we're going to look at some of the review exercises from Chapter 19 pertaining to sample surveys. In our first exercise, a survey organization is planning to do an opinion survey of 2,500 people of voting age in the U.S. True or false, the organization will choose people to interview by taking a simple random sample. It's hard to know necessarily. But if we are going to do an opinion, let's think about this one logically. If you want to do an opinion survey of 2,500 people of voting age in the US, that's a huge population, and it's highly impractical to do a simple random sample of such a large population. Because remember, when you have that your population needs to be clearly defined, and while we could say the US population is people of voting age in the US, that's a clearly defined population. It's still huge, and you certainly couldn't come up with a list of all those people without great effort. It just consumes too much resources. So simple random samples are just not practical for this purpose. They might use cluster sampling, for example. Our next problem has one study on slavery estimated that a slave had only a 2% chance of being sold into the interstate trade each year. This estimate turns out to be based on auction records in Anne Arundel County, Maryland. Is this trustworthy? No, it's not. Very good. Why not? Because this county might be exceptional. It's just one county, and in fact, it is exceptional. This is just a specific small county, and we would really, if we wanted to get a reliable estimate here, we would need to look across auction records for a variety of counties, and not just in Maryland. Ideally, we should look in across other states too, because if we just looked at slave auctions in Maryland, that would be very problematic because we're looking at the chance of being sold into the interstate trade each year. Well, different states might have had different rates of selling slaves into interstate trade. We certainly know it's true that different states embraced, let's say, or that different states had different rates of the frequency of slavery or slaves. And so Maryland does not give us a good sample here. And specifically, in this example, Anne Arundel is a very small county, and in the state of Maryland, there are two main slave auction houses at the time that were in Annapolis and Charleston, or the two main slave houses of that region at the time. And so we can only account for this one county area. We could theorize about the socio-political trends that would have led to this being so unrepresentative more, but let's, for time purposes, look at our next item, which is a hypothetical. A survey is carried out by the finance department to determine the distribution of household size in a certain city. They draw a simple random sample of 1,000 households. After several visits, the interviewers find people at home in only 653 of the sample households. Rather than face such a high non-response rate, the department draws a second batch of households and uses the first 347 completed interviews in the second batch to bring the sample up to its planned strength of 1,000. The department counts 3,087 people in these 1,000 households and estimates the average household size in the city to be about 3.1 persons. Is this estimate likely to be too low, too high, or about right? Well, I see we've got people coming in on both sides of too low and too high. Well, you're right, it's not about right. So it is going to be one of too low or too high. Let's think through this logically. With smaller households, the interviewer is less likely to find someone at home. So the survey procedure is, on average, replacing smaller households by larger households, because the survey procedure includes the interviewers visiting people at home, going to homes and trying to find people when they're at home. So this estimate is likely to be too high. A coin is tossed 1,000 times. There are two options: to win $1 if the number of heads is between 490 and 510, or to win $1 if the percentage of heads is between 48% and 52%. Which option is better? Well, this is pretty clear that option 2 has got to be better, because you win if number of heads is between 480 and 520. Oh, whoops. Ugh. So oh my gosh, I'm gonna do the same thing twice. So we clearly have 480 to 520. If we multiply multiply out the percentages here, I can do the math. I just can't write it out, apparently. Exactly. So this would be another way to think about this, is that this would be translate into a range of 49% to 51%. One hospital has 218 live births during the month of January. Another has 536. Which is likelier to have 55% or more male births? Or is it equally likely? Well, to do this, we have to look at think about how the size of the hospital is going to affect our likelihood of having 55% or more male births. With a smaller hospital, we're more likely to see this outlier percentage. As the size of the hospital goes up, the percentage of male births gets closer and closer to 52%. So the first/smaller hospital is more likely. That is an excellent answer, Stephanie. The first hospital has a greater probability for chance error of having 55% male births versus the average 52%. The second hospital is more likely to represent the average because as the number of trials increases, the proportion gets closer to the true parameter. We're very well put. You win a kitten. And here we have our last problem, which is pretty fun. A sorcerer has hidden a Porsche in one of an infinite row of boxes. The sorcerer will let you drive away with the car if you can find it, but you are only allowed to look in 11 boxes. He agrees to give you a hint by tossing a coin 100 times and counting the number of heads. He will not tell you this number or the number of the box in which he hid the car, but he will tell you the sum of the two numbers. I think that I'm missing the second part of this item, am I not? Let's see here. Yep, that's what I was saying. My notes have them. Oh, here we go. Okay, that looks better. Let's grab this. Will give us some space. Okay, and we have 4 different scenarios. If the sum is 65, which 11 boxes would you look in? Well, we have to sorry. One moment. So let's remember that what is the sum that we are looking at here? First, you get the hint, which is the number of heads out of our 100 coin tosses summed with the number in which he hid the car. So if the sum is 65, which 11 boxes should we look in? We would look in boxes 10 through 20. Boy, this has got some tricky probability things in it that I know you're all thinking, boy, is this going to be on the exam? No, it's not. This is a bit tricky, although it does remind me of, there's a similar idea, but much more clearly illustrated in a classic problem. Yeah, I would say I'll give you the answers here, but I don't think I'm going to give you a simpler example to walk you through thinking through how the probabilities change. So B, we're just replacing, we're looking at a sum, if the sum is 95. And C, the general rule here is to get to the center of the range, you take 50 from the sum and then go 5 either way. I feel like this resembles some of the grading you see on standardized tests, like the from okay. So that makes sense. You take 50 from the sum and then go 5 either way. And if you follow this rule, how likely are you to get the Porsche? %73%. Oh my goodness. One moment. Go, please. Like moly. I know everybody goes crazy this time of night. Okay. Yeah, I think maybe Stephanie, you have an earlier edition than we do, which is no problem, as you probably already realized. The uh, exercises are very similar, especially between the third and fourth editions. I had the first edition at the beginning of the semester. The exercises were not as similar. Well, that's funny. Well, I don't know why. I have both the electronic and regular fourth editions now. Please, funny face, go. It's okay. So I would say don't worry about this problem as it's a good thought problem, but I'm not going to give you a problem like this on the exam. What kind of sampling problems are you likely to see on the exam? Ones that are more similar to the earlier problems that we looked at. 9, for example. Eight looks like a nice problem. You know, just if I'm looking at these sampling problems and thinking about how they might translate into things you'd see in the future. Those are ones that are, have some calculations, but they're simpler. So at least in, oh my gosh, I'm sorry. It's insane here. So I'm not going to give you any terribly difficult or tricky probability problems. I'm most concerned with applications of the normal approximation. And remember, when you're studying, once we accept our limits, we go beyond them. What does that mean for us? Well, we accept that we're not going to get every statistics problem we try right. We're going to get a lot of them wrong, and then learn from that and go beyond what we thought our limit was once and achieve ever greater heights